Myself Shivakumar. I am here to explain the topic Artificial Intelligence, Exchange Signal Processing and Configuration Intelligence Surface Communications. Introduction. Abstract Reconfiguration Intelligence Surface (RIS) is an emerging meta surface that can provide additional communications like through the reflecting the signals and has been recognized as a strong candidate of 6G mobile's communication system. Meanwhile, it has been recently admitted that implementing artificial intelligence (AL) into RIS communication will extremely refine the recommunication capacity and change the raw materials to complicate transmission environments. Beside the conversation model driven approaches, AI can also deal with the existing signal processing problems in a data driven manner by designing the inheritance characteristics from the real data. Hence, AL is particularly suitable for the signal processing problems over RIS network under since likes modeling missing inefficient resource hardware implement as well as dynamical transmission as one of the electoral survey papers will introduce the margin of AL and RIS called ALRIS over various signal processing topics including environmental sensing, channel equitation, beamforming designs and resource scheduling, etc. We will also discuss the challenges of AI RIS and present some interesting future directions. Standing at the beginning of the 50th generation 5G, the communication admired and industry has started the resource procedure of the next generation communication system 6G in which the typical form workers of 5G example an exchanged mobile broadband, the ultra low latency communications URLLC, and the massive mission type communications MTC. Demand for the future en- engagement to cover all the requirement a variety of technology booms up. For example, a passive metal surface called the Reconfiguration Intelligence Surface (RIS) has drawn the extensive attention whom general application is to fight against the blockage of the line of the SIG LOS path and improve the communication quality through efficiency recognition the progression of electromagnetic EM signals. S. John and M. Lee are with the State Key Laboratory of Integrated Service Networks. Accidents University XI and 10071 PR China. Email Zaidasan at the rate extenia.edu.cn. Mail 96 at the rate state dot xden.edu.cn. MG Gian and Y John are with Electromatic Department of Wireless Product RD Institute ZTE Corporation Chilling 10029 China. Email gia.magnia at the rate zte.com.cn. joya.agin1 at the rate zte.com.cn. F. Goa is with Institute of Artificial Intelligence Teaching University THUAI State Key Lab of Intelligence Technologies and Systems Teaching University Belgian National Research Center for Information Science and Technology BNR ST, and Department of Automation is University Benjin 100084 PR China, email fiochio@IEEE.org. To enhance the performance of RIS communication, several critical signal processing issues should be addressed. The environmental sensing, the channel acquisition, the beamforming design, and the resource scheduling. The environmental sensing is to get the localized or the images of the objective with the head of head of the RIS. The channel acquisition is to either obtain the accused channel or the visual channel at both sides of RIS with is more complication those it conversation MIMO system. Note that different channel that informations CSI will result into the different stages into the subsequent beamforming design. The beamforming design is a key issue where the phase shifter of the RIS should be well controlled to eject the reflected beams in the desired direction. Moreover, the resource scheduling, including the joint scheduling for the beamforming of multiple base stationers BSS and multiple RISs, the user location and the BS power allocations, which can help control the optimum network topology and improve the system efficiency. For example, the user RIS pairs or even the user RIS BS linking can be well scheduled such that the users a close position and can be separately served by different BSS. Diagram sensing and channel acquisition of RIS communication. Sensing channel acquisition, image based sensing, channel prediction in mobile sensor. Key idea of AL based technology in RIS communications. RIS communications, AL based technology, environmental sensor, channel acquisition, beforming design, resourcing, scheduling, and then motion data driving, non-linear mapping, utilizes, advantages. Signal mapping, different double SMD and Robitons at creation will lead to large time composition. Hence, it is required to select a much smaller number of RIS features while simultaneously maintaining the SMD to ensure the localized accuracy. Since selecting optimal RIS features for the hug set of all possible candidates is very difficult, the authors of it implies supervised learning based schedule of the RIS future selections, which can reduce the time cost of position acquisition and similarities, enhance the localized accuracy. Image based sensing, an image based sensing techniques is proposed to fully exploit the reserved signal power at each RIS element, where the power sample and proceed to the generation a high resolution imaging of the progression environmental. Beside the authors sought to the transform learning and the support vector machines and design a computer vision algorithm to detect over a predictive route. Approximately 16 times less transmission overhead compared to the centralized learning based training while perform a similar way and then domain exploitation due to the large scale of both the BS and then arrays and the RAS elements. The direct estimation of the RS channel will lead to a training overhead. One solution is to reconstruct the channel matrix for limited measurements through compressive sensation technology. However, compression seniors approach needs complex mathematical operators and it's not robust to the noise measurements. It was recently shown that the full channel can be exploited from the particle 1 by ALS approach. For full possessive arrays, the extrapolation of the full scanned channel can be implemented at the terminals. Example, the BSS or the users in the authors about the ordinary differential equation ODE and set up connection between different data layers in the concentration neural network CNN, which can approximate the mapping between subsampled channel and the full channel better than common CNNs. Mainbelin recently designed hybrid activity passive arrays achievements. Some RS elements are enabled with signal processing ability. Thus, the estimation of the individual channel can be directly implemented at the RIS. In the author's active differentiation of RIS elements, recover the individual channel at the actuated elements and they exploit the full divisional channel information from the partial ones where a CNN is dissipated. Moreover, the authors propose an instant selection network based on the probabilist sampling theory to select the optimal location of those active RS elements. Both 19 and 22 have also be applied for the time domain stimulation over the high mobility scenarios. The second approach is extremely designed original exploitation network in order to deal with the error combinated inputs. This method can simplify the whole AL structure from the channel exploiting the and reducing the message passing completing among the NNS estimated before forming. The most implemented advantage of RIS communication comes from the performing that can control the signal reflection towards the desired direction and improve the quality of the transmission. This can be achieved by constantly turn the pace shift and the reflecting implementation of RIS elements. However, the high precautions achievement will be result into significant hardware cost of challenges in the realizing to control circuits and implementing a design achievement pace shift and amplitude. For us more abstract, here will be present typical AL based beform design string over their kits of sensors. Example, the full passive RAS, the hybrid passive active RAS, and the high mobility case as shown in figure 4. This beamforming design will be limited, which will harm the performance of continuously programmed based schemes in 28. In 22, the author constructed a beamforming codebook with the aid of the DFT matrix and the optimal beamforming selecting from the codebook can be reached by the classification problem. This is the author design a fully connected neural network FNN based classification network to jointly obtain the optical advanced reflection element pattern and the searching beamforming matrix of fiber passive active RIS. Introducing the exploring CSI, the performance of beam searching in closer to its upper boundary when the sampling rate of the active element is large than 1 by 8 C. Beam tracking the high mobility center for high mobility mobile challenge of RIS beamforming design is to precisely match the time varying characteristics. In 34, the author considered THZ Dora network, where a mobile user is seriously by a BSN flying RAS based on the period observation of the beam transferring. DL algorithm is provide the to product the optical 566 male RS beforming due to the mobility of the door get GRU based network structure is utilized for capturing the temporal correlation with the spectrum data and learning the sequence dependency. Thank you.